Hello everybody, today we will talk about the first type of the reactors which is used in the chemical engineering industry. There are many types of reactors you will face during your journey through the chemical engineering industry. One of the most important of them is the CSTR reactor. Um, First of all, I want to clear that the CSTR reactor, actually I underestimate this reactor. This reactor is very complicated and not as you used to think about this type of reactor. It is not so simple as you think. Continuous stirred tank reactor is very important. You can find this type of reactor in the polymerization industry, in the pharmaceutical industries, and we will see how the design related to this type of reactor is very important, controlling the conversion of the reactants. I think this journey will be amusing for you. First of all, CSTR. This is continuous stirred tank reactor, which means that you will face a tank, and inside this tank there is agitator, okay, and there is an inlet and the outlet from this tank. Is it all? Not like this. You will see through the lecture that you have some kind of feed enter continuously and the product leave continuously, okay, or you can find the process happen batch wise. So maybe you will work with the continuous stirred tank reactor in this way. You have feed in, and you have product leave. Or you can make it batch-wise, which means that you put the reactant inside the continuous stirred tank reactor, implement the conversion, achieve your conversion, then you dispatch this conversion. Through the CSTR, we need to achieve perfect mixing. So the agitator and the agitation is one of the most important parameter we will discuss in detail. Okay. Normally, this type of reactor used for the liquid phase reactions. How continuous stirred tank reactor work? Agitator ensure the complete mixing between the reactant. Reaction occur at constant operating condition normally. Okay, you stabilize the pressure or vacuum, you stabilize the temperature, okay, you stabilize the agitation speed. So the reaction occur at constant operating condition. Temperature controlled by jacket or internal coil. So this idea we will see through the charts, that you control the temperature of the reactor by controlling the coil outside the reactor or by some baffles internal. Outlet composition same as inside the reactor. Here simply you can find the chart clearing and revealing the main component of the continuous stirred tank reactor. Here you can find reactant number 1 and reactant number 2 going through the continuous stirred tank reactor, and here is the agitator make steering inside the tank, inside the reactor, okay, and there is motor to control the agitation speed, and here there is a coolant, for example, because in some continuous stirred tank reactors we need to cool the reaction, and otherwise we need to heat the reaction. Okay, you add Q, you remove Q, so you control this by the jacket. I think this is a simple idea. Okay, coolant here, and this coolant go out from the coil around the reactor. I want to show you one reactor from the real manufacturing industry, like this reactor. Look, it is not so simple as you think. Okay, here this is some kind of continuous stirred tank reactor used in the polymerization process. Okay, many parameters we control through this reactor. You will find the pressure. This polymerization process work under a vacuum, so there is evaporative cooling achieved by this equipment additional to the reactor by evaporating and make cooling and make a return reflux to the reactor. There is a weight feeder, which weight sensing element to control the residence time inside the reactor. There is a coil, this coil to adjust the temperature of the reactor here, and there is a baffle to make good mixing inside the reactor between the reactants. So what I want to tell you that it is not so easy as you think the continuous stirred tank reactor. We need to study the main item composing this type of reactor. What is the main parameter related to this type of reactor? The main parameter related to this type of reactor is temperature. We need to control the temperature. As we mentioned before, in the polymerization reactor, the temperature may be controlled by coil controlling the body of the reactor, and the temperature also can be fixed by make a reflux by evaporative cooling. You can take the vapors from the top of the reactor and make cooling and return back in the liquid phase to the reactor. So the main parameter to control through the continuous stirred tank reactor is temperature, one of the most important, and we describe the idea of coil and how you can control the temperature by the coil inlet flow and the coil outlet flow. The second item, mixing speed. Mixing speed is very critical parameter related to this type of reactor, mixing speed. And for this, we control the agitation speed by adding variable speed motor, okay? Because in some cases you need to increase the speed or decrease the speed to control the conversion. I think it's very, very simple to understand that when you increase the speed of the motor, you increase the speed of the agitation, so you increase the conversion. And normally when we talk about the continuous stirred tank reactor, we face a cumulative conversion, which means that you have R1, R2, R3. R1, which is reactor number 1, give you conversion like 25. Then you go through R2, increase the conversion, maybe 50, and R3 maybe you reach to 75%, and the other may be treated by the recovery system. So this is a cumulative conversion. So the mixing speed and agitation speed is one of the most important parameters related to the continuous stirred tank reactor. The residence time. Residence time is very, very important. You control the residence time maybe by weight feeder or by controlling the outlet flow from the reactor. The feed flow rate impact also the conversion, and you can increase or decrease the feed flow to the reactor to impact the conversion. Additional parameter can be considered like the catalyst, because you can add some catalyst or to increase the rate of the reaction, or you can add some inhibitors material to just decrease the rate of the reaction and to control or slow down the rate of the reaction. Here the pressure maintained liquid phase. The pressure can be positive or negative related to the design of the continuous stirred tank reactor. pH is one of the considered parameters. This is related to the in biological industry. You control the neutralization and the pH by pH meter, immersed the element related to the pH meter inside this reactor. So we discussed the agitation. We considered agitation one of the most important. Here is the motor, variable speed or fixed speed. This is very important point, and I want to clear here, when you make interlock system to protect the reaction rate or protect the equipment, you consider standby source of electricity related to this motor, because if you lose the electricity from the source number A, you can add or use number B, cut in immediately, not to stop the reaction inside this reactor, okay? Here, baffle inside, coolant jacket, feed in like this. The troubleshooting related to the continuous stirred tank reactor. High temperature. If you are working for manufacturing polystyrene, polyvinyl chloride, whatever the industry, sodium tripolyphosphate, for example, you can face high temperature inside the continuous stirred tank reactor. This may be related to the cooling system failure or fouled coils or jacket, which means it is not clean. You need to shut down and make a clean or removing for this fouling material. High feed concentration can be considered or low agitator speed. The action here will be increase the cooling, reduce the feed, clean the heat transfer surface. Low temperature, if you face a low temperature working with the continuous stirred tank reactor, so excess cooling maybe this is the source of this low temperature, excess cooling for the reaction. Low feed concentration, A plus B with concentration lower than the normal. Low reaction rate or deactivated catalyst. You add catalyst or initiator and this initiator not properly working, okay? The action related to this problem is to reduce the cooling rate or check the catalyst or increase the temperature. Poor mixing. Poor mixing affecting the conversion directly. So the low RPM, damage impeller, high viscosity, all these symptoms related to the efficiency of the agitation. Here you can check your agitator, you can increase the RPM, and inspect your mixer and add buffle when you make your design or redesign for the reactor, and we will see the types of agitator in detail later. Here the troubleshooting, low conversion. Short residence time can make low conversion. The catalyst deactivation, like the initiator or the catalyst deactivation, can cause low conversion. Low temperature can cause a low conversion for sure, and the feed impurities, not the feed rate, the feed impurities. You can introduce the feed reactant A plus B with the recommended rate, but there is some kind of impurity, decrease the rate of the reaction, you have to remove, okay? The action is reduce the flow, increase the temperature, or replace the catalyst, or check the catalyst itself, okay? This troubleshooting related to level issue, the feed instability, outlet valve issue, foam forming or gas entrainment. So the action will be stabilize the feed flow, check valve can be add or review your hazard recommendation sheet, add anti-foam or stabilizing a material. So the key performance indicator related to the first type for our reactors here in our lecture is the conversion, energy consumption, the heat transfer performance, and the catalyst activity temperature uniformity. So we repeated the word conversion many times, and we see that it is one of the core items related to the continuous stirred tank reactor is to control the conversion. So one of the most key performance indicator, how you control the conversion, how you achieve the required conversion, controlling all the parameters we discussed before, like the agitation, the temperature, your pressure, your coil temperature to keep the reactor at the recommended A parameter as we mentioned. In the next section of our lecture, we will discuss the design of the blades of the continuous stirred tank reactor. As we mentioned before, that the blades is one of the most important part or element help you control the rate of the reaction inside this type of reactors. So the agitator, and we mentioned that we need to keep all time two sources of electricity available for the motor, source A, source B. If you lose the source A, you can use cut in and introduce source B, not to stop the agitation, and maybe this lead to runaway, and the runaway reaction not recommended at all for this type of reactor, because it may be harm the equipment and make them